Alright, so today we're doing translations and reflections. Alright, so definitions part first. This is the boring part. Transformations is a change in the position, shape, or size of a figure. Kind of like Transformers. They transform from a car to a robot. Well, that's a transformation. It changes in shape, position, or size. Alright, transformations have different types of transformations. So like translation is a transformation. It's a type of one that moves each point of a figure the same distance and in the same direction. Basically, you're taking the figure and you're sliding it. Either up, down, left, or right. You're just sliding it. That's a translation. Some more definitions. Image. Image actually has a definition in math. It's a figure after a transformation. So an image is a figure after a transformation. Reflection is a transformation that flips a figure over a line called the line of reflection. So basically it's like looking in the mirror and seeing yourself. That's reflection. And the line of reflection is the mirror. Okay, last two definitions. Reflectional symmetry. When a figure is reflected over a line, so its image matches the original. That'd be like the mirror thing again, but it has to be perfect. It has to match perfectly. When a figure is reflected over a line, so its image matches the original. Line of symmetry is that line that it mirrors on, so it would be like the mirror. Alright, here's an example. Alright, see, we want to translate the regular P that's right here to P prime. It's our new P. Anytime you want to change a letter to something else or change an object to something else, this prime sign right here is given. And that just means it's a new value. It's the same one, but we've moved it or done something to it. Alright. So to change, alright, so I'm translating to P to -1, 2. So the first thing we have to do is label P prime. We're going to go over -1, that's -1, and down 2, 1, 2. Don't forget this is X and then Y. This is my X-axis and Y-axis. Alright, so I went over 1, down 2. Oh, I did that wrong. My bad. This is X, this is Y, so we go left 1, up 2. So this is the new P. Alright, so I have moved the R out of the way so it's not in the way anymore. Now we want to figure out how we go from P to P prime. Well, let's look at it. We went 1, 2, 3, 4. Now that's 4 for which value, X or Y? It's X because this is my X-axis and Y-axis. So I went 4 for X. And how much for Y? Up 1 for Y. Now, I've added 4 because I went to the right on the number line, on the X-axis. And all these are positive values, so I got bigger. Also went up 1, so it's +1 on the Y. So now, how this works is I translated it. I moved it 4 to the right and up 1. So I'm going to move all the points like that. I'm going to move them 4 over and up 1. So, alright, we already know where P prime is going to end up. It's going to end up right here. However, I'm going to show you how to get it with the points. We had to go to the right 4, X changes by 4, and Y changes by 1. We established that right here. So now what I'm going to do is actually do it. I'm going to add 4 to negative 5 and add 1 to 1. And my p prime now should be negative 5 plus 4 is negative 1, and 1 plus 1 is 2. Let's check it out. Negative 1, up, 1, 2. So it ends up being right. Alright, so we've got our p prime, it's negative 1, 2. Now let's try the other points. Erase p. And now we're going to try q. Q is negative 1, comma 4. So it should change the same amount. It should translate or slide the same way. So I'm going to add 4 to negative 1. And I get 3. 4 plus 1 is 5. So it should translate to 3, 5. So 3 for x, 1, 2, 3, and up 5. 1, 2, 3, 4, 5. So there's my new q. Now I'm going to erase some things to get things out of the way and make it look prettier. So I've changed my q to q prime to 3, comma 5. Now that I have that, I'm going to do the last point, which is r. So let me write down r. r is negative 2, comma 2. So I'm going to try to find r prime. So I'm going to add 4 and 1. So add 4 to x, I get 2. Add 1 to y, and I get 3. So my new point is 2, comma 3. Let me graph that. 2 would be 1, 2, and up 3. Right there. So now I'm going to make my, actually I'm going to put the point down. So r prime is 2, comma 3. Now I can connect the points on my triangle, my new triangle. There, there, there. Now you see how it's the same exact triangle? It just got shifted up and to the right. Got shifted up 1 and to the right 4. And that's a translation. It's a slide. Alright, so here's a new problem. We want to figure out how far it's translated. We know it's a translation because it's the same figure and it's been moved to the right and then moved down. Alright, so we want to know how far x changed and how far y changed. Which is the translation? So this is how we're going to figure it out. I'm going to pick a point. So I'm going to pick t because it's on the bottom. It went from here down, oh, sorry. It went from here down 1, down 2. So if I went down, that should be subtract 2 for y. And x, if I went to the right, 1, 2, 3, 4, then I'm adding 4 for x. Okay, so now we know that x is going to be added 4 and y is going to be subtracted 2, and that's how much it shifted. It's just shifted down 2 and to the right 4. So up and down is y, and left and right is x. Down 2 and right 4. So let's actually figure out the points just by doing that. Erase these arrows. Put t back up there. Now let's figure out our t prime. T is negative 2, comma 1. And we want to find t prime. To do that, we're going to add 4 to x and subtract 2 from y. So we get t prime is 2, comma negative 1. Let's try it out. You go 1, 2, down 1. Perfect. Now let's try r prime. Right, here's R. So R prime would be add 4 to negative 3, you get 1. Subtract 2 from 3 and you get 1. So our new R prime should be 1, 1. Let's try it out. Over 1, up 1. Works out. We did a good job. Now last we're going to do S. S is 1, 2. S prime, you're going to add 4 to 1, so that's 5. Subtract 2 from 2 and you get 0. So it should be 5, 0. That means 5 for X, 1, 2, 3, 4, 5, and it stays right there because it's 0 for Y, it doesn't go up or down. So we have a translation. Our translation means that it went up, or right 4 and down 2. Alright, line of reflection. Now we're doing reflections. So this one wants us to have a line of reflection at X equals 2. So that's what we're going to do. First we have to find X equals 2. Well, here's my X. And here's my Y. So X would be right here. X equals 2. Well, close to right there. X equals 2. So that means on this line, right here, I need to reflect. So how you figure this out is you figure out how far each point is away from the reflection. So let's test out. C is 1, 2, 3. So I go back on the x-axis over here and I'm going to do 1, 2, 3. That's C prime, right here. Now B is the same way. It's at Y equals 1, 2, 3, so I'm going to have to go up 1, 2, 3. As you can see, it's 1, 2, 3 away from the reflection line, just like over here. Alright, and A is 1, 2, 3, 4, 5, 6. So that's how many we have to go. 1, 2, 3, 4, 5, 6. Now it's at Y equals 2, so we're going to put 2 here. Now a lot of people get confused with this one because this is how they normally do it if they were to do it without actually using the points. As you can see, it is a reflection, but that's not how we really need to do it. We really need to look at the points themselves. It makes it a lot easier. So let's figure out what C is. C is negative 1 for X and 0 for Y. A is negative 4 and 2 for Y. And B is negative 1 and 3 for Y. Now let's check over here our reflection. C is now 5, 0. A prime is 8, 2. And B is 5, 3. Now if you notice something, all the X's, all the Y's, right here, all the Y's are the same. They stayed the same for each point. They didn't change. The X's do change. And let's see if we can figure out a pattern how they change. So this is how they change. You go from negative 4, let's look at A, right here. We go from negative 4 to 8. Now, if you've ever looked in the mirror, reflections are double the distance away from the mirror. So if I'm 2 feet away from the mirror, then my actual reflection is 4 feet away, because I'm looking at 2 and I see the mirror, and then there's 2 back from the mirror back to my face. So it's double the reflection, double the distance. So if we're looking at the 4, it's how far away from x equals 2? It's 1, 2, 3, 4, 5, 6 away from x equals 2. And what's double 6? It's 12. So if we take negative 4 and we add 12 to it, we will get 8. And that's how you get this point right here. The y stays the same, only the x changes. So let's try it out on the other points. Let's try it out on C. Here's C and here's C prime. How far is C away from the reflection line? Let's see. 1, 2, 3. It's 3 away, so double 3 would be 6. So if we take negative 1 and we add 6 to it, I should get 5, which is right. And it also works for B. B happens to be the same distance away. So it starts at negative 1. We're going to add 6 to it, and we get 5 again, just like right there. Alright, and that's how you do reflection. Only x changes, unless the reflection line is horizontal on the y. Then only the y changes. So here's one more. This one's kind of different. It says, what is the line of reflection? The line of reflection is one that mirror images. So we can see that there's a copy up and down from each other. So we know that the line of reflection has to be on the y-axis. Has to be on this y-axis right here. So we want to figure out how far they are away from each other. Well, it's 1, 2, 3, 4. 4 away from each other. So remember, the distance is... Alright, so we're 4 away. And we've got to remember that the mirror is double the distance. So what's half of 4? It's 2. So we know our line of reflection has to be at y equals 2. Right here. It's y equals... Oops. Equals 2. And that's our line of reflection. That one's pretty easy. Alright, that is the end of the notes today. I'm sorry they were extremely long, but we'll work on it tomorrow and we'll see different types of problems.